Hello, in previous video I showed how you can work with Docker file to bundle up your Docker images, and then I also told how to shift your Docker images to the Docker Hub as well. In this video I'm going to show you from how you can deploy your Kubernetes deployments or your Docker containers in your Kubernetes cluster. Imagine you have a all set cluster. So first thing we need to see the number of nodes in our Kubernetes clusters. For this, we can see this by showing the kubectl get nodes command. So it will show me that the number of nodes which is currently running in my environment. If I need to see whether I'm connected to the which cluster, so I can see it kubectl dash cluster dash info. This will tell me to which Kubernetes cluster I am connected to it. Right now I'm connected to it like upworks dash vpc. This is the Kubernetes cluster I'm currently running my stuff. If you need to see some more details, so you can issue the cluster kubectl cluster info along with the dump. This will give me a detailed insight about my running cluster, about the nodes, about the logs, and about the daemons which are running, and it also tell me some sort of logs for my cluster as well. So this is our target for this video. In this video, our target is to show how we can deploy our Kubernetes, how can we can run our Kubernetes cluster to run our Docker container. Imagine we have we need to run our MySQL container in our Kubernetes cluster. Kubernetes has several methods to deploy services in it. So for this, Kubernetes has some sort method for like replica sets. This will ensure that number of Kubernetes Docker container runs on your Kubernetes cluster. The things which we are seeing over here is the way we can run our Docker container in our Kubernetes cluster. In first, we bundle up everything in the Docker image, and then we push that image to the Docker Hub or Docker registry, and then the time which it requires to run our Docker container in our Kubernetes cluster. So these are the methods which we are currently seeing to run our Docker container in our Kubernetes cluster. Replica sets, application controller, daemon sets, and the deployments. Replica sets is actually ensure that the number of pods is always available in your Docker Kubernetes cluster. Replication controller is a pretty old method. It will similar to the replica sets, but it has some minor differences between the replication controller and replica set. The another way is the daemon set. Daemon set will ensure that your Docker container is runs on each node of your cluster. Currently, we have two nodes, kubectl get nodes. So daemon set will ensure that your container is run on your all worker nodes. Just imagine currently we have two, and we upgraded with one Kubernetes node, worker node, then daemon set will spawn up a container on the third worker node as well. So this is for normally for kube systems or the system containers. It is recommended for the services requires a very high availability and across the nodes, so we can use the daemon set. The last, which is the fashion method nowadays, is deployments. Everyone is using the deployments. Deployment is the combination of replica sets and the replication controller. So it will ensure that the number of pods and run in your Kubernetes cluster. Also, it will ensure that the blue-green deployment concept in your application deployment cycle. So this is the thing which we're going to deploy our Docker container in our Kubernetes cluster. By default, Kubernetes Docker the running container in the cluster is not accessible by other containers running in the cluster. So what if we need to expose our imagine that we spawn up a MySQL container in our Kubernetes cluster, and we have a WordPress app and we need to access we need a WordPress container to access the MySQL container. So what happened by default, this communication is restricted. So this in order to enable these communication, what we need to do is we need to enable a service that is known as Kubernetes service. So for this, what we need to do, we need to place an intermediate service to expose our Docker container. So it will be service that uh, interact with that allow WordPress or MySQL container to talk to each other. By this, by having service on top of your deployments will enables your other containers running in the cluster to access the service. Imagine that MySQL WordPress need to access the MySQL container. So what it will happen, it will access MySQL service, and MySQL service will route the traffic to the MySQL container or MySQL pod. So under the MySQL pod, the traffic will be redirected to the specific container. So that is how we can access our Kubernetes services to each other. We're gonna see the deployments and the services method in this video. So let's begin. The first thing, imagine that we are asked by our teammates or deployment teams to set up a MySQL container uh, in your Kubernetes cluster. So we can start with a deployment file. So first we're going to create a Docker deployment, Kubernetes deployment file. Kubernetes always understand the YAML format or JSON format. So for now we are using the YAML format. In the deployment, we always start with 3 hyphens. This will indicate the Docker Kubernetes engine that this is the deployment definitions we are going with. So first thing we need to specify API versions. API version is nothing accessing methods for the YAML templates. So in this, I'm gonna use uh, apps API version with API version 1. So the next thing which we need to specify is the kind. As we already discussed that there are several kinds, so we are going to use deployments. So deployment is the kind. Now we need to specify the metadata. Metadata is nothing but just a definition. So metadata, first thing in metadata we need to specify the name of the deployment, which for us is MySQL. So we're gonna give a friendly name for our deployment. Now we need to specify some specs for our deployment. So for to specifying the specs, we can initialize the specs selector. Now we need to initialize the selector, which actually used by the kubectl proxy. And in this, we are saying our selector to match labels. So match labels, in match labels, we are saying our kubectl proxy to use the app label, and the app label name is MySQL. Now we are saying our deployment to use a strategy in case of replica sets in replication control invokes. So strategy, and we need to specify our strategy. There are several types of a strategy. We are currently using the recreate strategy, and we can use the restart always as well, and there are other as well. So now we need to specify the template of our deployment. Again, we need to specify the metadata of a template. In the metadata, we are starting with the labels. First, we are giving the label to our app. So MySQL proxy, kubectl proxy can see this app label to route the traffic. App, in our case, it would be like MySQL. And next thing, we need to specify the specs of the container. Indentation is very important, so always ensure that you are using the correct indentions. So the selector template, selector and the template should be aligned on the same selector, and the template should be on the selector strategy should be because we strictly need to follow the intention, otherwise your deployment will fail. We need to ensure that everything related to template selector should be in the same line. Other intention is very important. So we already specify. Now we need to ensure the specs should be underneath the template, because it's a part of template. So we are going to specify from here spec. Oops. Okay, in specs we are defining containers. Okay, containers. In containers we are going to specify the image name. Image name in our case is MySQL colon 5.6. Okay, now we can give the friendly name to our container. We are currently giving it the name as MySQL. So now the next step, we need to specify the environmental variable. In MySQL case, we can specify MySQL username and password through environmental variable. So we need to specify the dedicated environmental variable, which is MySQL underscore root underscore password. So this is the variable which actually used by MySQL to set the password. Now we need to give the value. The value is I'm just giving it a friendly password. We can use the base64 encoded as well. So next thing, we need to specify the ports. And we need to ensure that ports is under the specs. Now we need to specify the container port. Indent, don't forget, indentation is very important. Container port is the port which going to be spawn up in the Docker container. So 336 is the container port, and we can name that container port as MySQL. So uh, this is our deployment file. We can deploy this deployment file using kubectl apply space -f deployment.yaml. Okay, it's saying some error, unknown field match labels. Sometime it happens because we are match labels, actually the spelling mistake. It should be BELS labels, and we can hit again, and it's saying that ports is unknown field. We can see ports where the ports is lying. Ports, ports should be under the containers, because it's containers port, so it should be under the container. So we need to very sure about the, so you can see the deployment has been created. If I can see kubectl get deployments, So it will show me that one deployment is running named as MySQL. Currently it's not ready with any container, any pod. uh, and if I need to see the pods, so I can issue the command kubectl get pods. So it's saying that image pull error. Okay, maybe we have given the wrong image name. Okay, L is missing, so you can see that we are putting so many errors, and we can see how we can resolve it as well. If we redeploy it again, so it will not change existing stuff. It will only apply the new stuff which we have added. So you can see that MySQL container is in running state. So this is the first step which we have done. Now the part which begin, like we need to expose this container to uh, accessible from the other containers. So for this we need to write a service file. We can call it as a service.yaml. In this YAML file, we're going to give some definition about how kubectl proxy can route the traffic to our deployment, and then deployment can route the traffic to the container, pod and then container. So starting with API version, again, this is all necessary. So we are going to use the version 1 API for the service. Now we need to specify the kind. Kind in our case is a service. Now we need to specify some metadata for the service. Metadata is nothing, just a definition. So we are giving the friendly name, MySQL service. So now we need to specify some specs to our service. Okay, there's a spelling mistake. I just got that. So in the spec, we are saying that to use the ports, and which port to use is, we are going to say that use the port 3306. And now we are saying use the selectors to route the traffic. Selector. Now we are saying use the selector, and in the selector you're gonna use the app label name. So app label name must be MySQL. And now we can specify the type, because it's a data store, so we always recommend to use the cluster IP. Otherwise we can say that type is equal to node port. So in this, what it will do, it will we can access our service by any of the worker node IP. We will see how we can access. So this is our service definition. So we can apply the kubectl apply space -f service.yaml. It will unchained, it will configured. So this is it. We can see the services with kubectl get svc. So our MySQL service is already deployed with the name. Now we need to see whether we can access this Kubernetes container, Kubernetes server part deployment, sorry, from other parts. For this, we normally use the Pragma network tool. This is normally I use for the debugging purpose. It has the all debugging required debugging tool pre-installed in it. So kubectl get pods. So now I need to access it. Kubectl uh, kubectl exec space -it, the port name, and space --bash. So the first thing which I need to see whether I can access my Kubernetes MySQL service. Where is my service? Here is the service. So first I want to see whether I can access or not. I'm just telnetting the MySQL port. Space oh, sorry, it should be VZ, not VC. The connection is being successfully made. Now I need to connect to the MySQL container. MySQL space -h. In the host name I will use the service name, which is this. So In the host, we need to use the service name and then the username. In our case, it's root, and minus p. We have used the password, simple password. So you can see that I can connect to the database. So I can create the database. Sorry, spelling mistake. I must write the wrong spelling. Data. So you can see I can work around with my Kubernetes cluster. So you can do a lot more stuff. You can specify your configuration, like if you need to specify the DB string in the host IP or name, you can just use the MySQL service name. So in this video, this is all we have from this video. In next video, we will see how we can configure the other stuff as well, like how we can interact the UI as well.